Right, hey, welcome. So here's just a small homework assignment that we had for CS 472. It's a computer architecture class. And the assignment was to use or program a MIPS disassembler. Now, it's not any sort of general disassembler. It's just specialized, little program to disassemble this small instruction set or set of instructions that was given to us. So here we go. Here's the program source code right here. These are the instructions I had to disassemble. Okay, so basically what I did was I created some masks that I'll use for my bitwise AND operations to get those bits out. And then basically what I'll do is I'll store them into the appropriate struct and their appropriate formats. Alright, so you get the R format, you get the I format, and basically here was the different opcodes we had to look for. I just created my own little data structure for them. Alright, so further on down I did these functions up here just to clear them up there to make the program easier, the main function look a little better. We'll go over those functions in just a minute. So here's my main function. Initially what I did was I allocated some space in memory for those formats, and I declared some pointers to them. Alright, and right here this is going to act as our program counter. Okay, so then we go into a while loop. So while those instructions, we iterate over the instructions, each one 32 bits at a time. And first case here is I basically said I bitwise AND the first 6 bits. Okay, well first with a mask, and then I shift those 6 bits into the most least significant bit, and bam, I have my unsigned integer as my opcode. Now in the R format, we know that all opcodes are going to be 0. So basically what I did was I said, okay, well if it's 0, we know it's an R format. The instructions in R format, so we put those 32 bits into our parse R function. Okay, right here we pass in the instruction plus the offset within that instruction array. We also pass through the opcode that we found, even though we didn't have to, but just to keep the format a little crisper, we're gonna because we passed through down there anyways, and then we print it out. We pass through the actual what the parse does is that you pass through a pointer to that memory location, and we store those bits in that format into that memory location. Alright, so then we print it out. And the same thing with the else, does the same thing except in the I format. Alright, and after that we just we increment the program counter and our iterator, and that's it, we're done. So now to the functions that we kind of use. Basically each assignment is a series of bitwise AND operations followed by a shift of those bits into the most least significant bit position. Alright, so the R format, the first 6 bits, the opcode, the second 5 bits. Well, the next 15 bits divided into 3, so each of 5 bits are the registers, and followed by this small little shift field that we're not really paying much attention to. We're just assuming they're all zeros. And then finally by the actual opcode, which is the function field that we use to get our instruction opcode. Alright, so parse I does the same thing really, except that time we assign the OPC code. We do those bitwise operations, the shifting, and finally for that constant, since it's a 16-bit constant, you only have, on the I format you have the 6 bits, 5, 5, and then the 16. The 16 bits, we can't, if we cast that into a 32-bit integer, then the most significant bit's going to propagate throughout the rest of those bits in those bytes. and we're not going to get the proper answer, the proper value we're looking for. So that's kind of fun. And then we just print out the R's, the R formats, and the I formats. Nothing really clever about the R format. It's just the typical. But what's fun is the I format, because we got a program for those cases where we have branches. Okay, so our branch codes are 4 and 5. Okay, and basically we have to follow another trick. We have to shift those bits over by 2. Okay. If you want to know why, you can look it up. It's kind of cool. But aside from that, those 16 bits, if it's a branch, they're going to be compressed. So we got to decompress them, okay, and then we got to add the program counter, okay, and then we got to add 4, okay, because our simulation isn't simulating the pipeline where the program counter would already be incremented, so we got to make up for that right there. And so, if it's not the I format, then we just print it out the regular way it would be, okay? And we're gonna run a little, we're gonna run it right here. We're gonna compile it first, okay? We get a couple warnings just because I do some funky stuff, but just so it's a lot cleaner this way. And then what we'll do is we'll run it so you can see the output, okay? So again, if you want to see the actual codes, and here's the result. So each instruction's got a memory, location, address rather, and followed by the actual MIPS instruction. Now we're not using, clearly you can see we're not using those temporary and those guaranteed register types, because just for the example in the homework we're just not using them. So there's your branches, okay, there's your ors, your ands, your stores, your loads. And I just, that's it. I just want to get this out there, and hope you guys, whoever's watching this, enjoyed it. All right, thanks. See you later.